Okay, so let's go over some of the kinematics questions that you had last night for homework. So first, number 3 on the back, which says two bicycle racers are racing along a straight course. Bicyclist A has a lead of 227.27 meters. So this is 227.27 meters. Okay, this guy's bike A, this guy's bike B. Now, there's a typo that hopefully you saw posted in the group. Bike A has 1,600 meters to go, not 1.6 meters to go. So the delta D for bike A is 1,600 meters. And so the delta D for bike B is 227 plus that. So that would be 1827.27 meters. Okay? It says that A maintains a constant speed, so VF, of 8 meters per second. And it wants to know what's the constant speed of B going to have to be if B is going to catch A right at the finish line. So if the finish line is somewhere up here, right, A has this far to go, B has this, but it has to happen at the same time if they're going to get to the finish line together. So if you can find the time for A, that will have to be the time for B. And then once you have the time for B, it'll be easy to find the VAV. So you're just going to use VAV equals delta D over delta T. So the time for A, delta dA, is just going to be delta TA, will equal delta dA over VAV. So 1,800 meters over 8 meters per second. So it means that A, 8 into 16, is 2. It means that it's going to take him or her 200 seconds to get to the finish line. Okay, so we now take that 200 seconds and we take it over here to B, and now we want the VAV for B. So VAV for B is just equal to delta D for B over the time. So 1827.27 meters over 200 seconds. And that will give you a VAV for B, move the decimal, divide 9.13635, I think, meters per second. And that's it. You're done. Just that easy. All right, number 4. Number 4 says you have car A and car B, and they're traveling to the right at 96 kilometers per hour. Okay, and it says car A is 6.096, so this distance, 6.096 meters behind B. And both of them are traveling 96 kilometers per hour. So for A, I think it's a VAV, and when you do that, that's 26.6 repeating meters per second. And for B, it's a VI, 26.6 repeating meters per second. Okay? When B suddenly begins to slow down, so this guy's going to slow down. So the acceleration for B is negative 7.3152 meters per second squared. How long will it be before car A hits B? So A's texting, A's drinking its ice cap, finding better tunes to listen to, doing whatever, but A doesn't slow down. Okay? And so doesn't notice that B is stopping. And so B is stopping, A is going to rear end him. So, and it wants to know how long. So, again, we would know that the delta D of A, so at some point, they're going to be at the same spot, unfortunately. So this will be delta dB, this will be delta dA. So if we do our equation, delta dA will equal delta dB plus the 6.096 meters. The equation for delta dA will just be VAV delta T. The equation for delta dB will be VI delta T 1/2 A delta T squared. And so we fill them in. So V av delta t will equal Vi delta t 1/2 A delta t squared plus our 6.096 meters. Looks blurry to me. I don't know if it looks blurry to you. Okay. And so the VAV and the VI are the same, so these are going to cancel. Bring your 1/2 A delta t squared over to the other side. It becomes negative. And then to solve for delta t, multiply by -2 to get your negative over there. Whoops, I think I added an extra 6 in there. Sorry about that. And then divide by A. So, whoops, and A is what? Saving steps. Yeah, okay, I'll write it out. So, -2, 6.096 meters, and -7.3152 meters per second squared. And remember, that's going to be t squared. So when you punch it into your calculator, don't forget to take the square root. Before you take the square root, I think it's 1.666, maybe a 7, maybe repeating, not sure. And then take the square root, and you discover it's 1.29 seconds. Okay, so, and that's all it asks. How long will it be? Yeah, it just asks the time. And then it says, what does this tell you about, say, following distances? Well, if you're going to follow that closely behind, then don't be playing with the radio or drinking ice caps or whatever, because you're not going to be able to stop in time. All right, the last one is number 5, is Willie and Millie. Now, just as a little background, Willie is Millie's younger brother, okay? And so he's dropping the flower pot on her head because he's the younger brother, and that's what younger brothers do. Actually, that might be what any brothers do. I'm not sure, having 3 older brothers. So here's the flower pot. Here's Millie. Okay? And here's her ear. So it tells you the height to the top of her head, and it tells you the height to her ear. And that's important because the pot's going to hit her on the head, but the sound has to go to her ear. Now Willie, after he knocks the flower pot off, realizes if he actually hits her, he's going to be in big trouble. And so he's like, he plans to warn her so that when his parents yell at him, he's like, but I warned her. It was an accident and I warned her. But he doesn't want to warn her too soon, because what fun would that be? All right, so to separate our givens, we have the plant or the pot falling, and we have the sound going down. Okay? So if we think about the plant, he knocks it off, so VI is 0. And gravity, 9.81 meters per second squared. Okay, and then it says he's 35 meters above the ground, so like he's in a window quite far up. So this whole thing is 35 meters, right? But she is 1.05 meters tall. So how far does the plant have to travel? It's the 35 meters minus the 1.5. So the plant has to go 33.95 meters. Okay, now it tells you sound, so the VAV for the sound is 340 meters per second. And the sound has to go all the way to her ears, which is 5 centimeters below the top of her head. So it has to travel an extra 5 centimeters. So the delta D for the sound will be 34 meters. Okay, now if you look at both of these, you should be able to realize you can get your time for both, right? So the time for this one, delta D is equal to VI delta T, 1/2 A delta T squared. VI goes to 0. So this will be T squared is equal to 2 delta D over A. So 2 times the 33.95 divided by 9.81 meters per second squared. And then again, remember to take the square root. So the delta D for the plant is going to be 2.63 seconds. Now you can also find the delta D for the sound. And for this, it'll just be VAV equals delta D over delta T. So delta T for the sound